Hi everybody, this is Mr. Corzine. I told you I would record something and share it with you, so here we go. We're going to work on the homework together. I'll make this look the best that I can, and then we'll get started. First thing is we're going to use precision. Oh, let's see if I can make this work. We want to use precision and measurement, all right? In our measurements, for example, 7 gallons or 14.2 gallons, both of those are just measurements, but we're trying to see which one is more precise, which one measures more closely to the actual amount. So what we see here is we have a number 14.2, and then we just have 7. 14.2 goes to the nearest 10th decimal place. 7 only goes to the ones place. Now, one thing that would make this different is if this had said 7.0. If it said 7.0, then both of these would be the same level of precision. I'll put that in there, precision, accuracy, because they would then be going to the same decimal spot, the nearest 10th. So what I want to do is, now that I've compared them, I can now say very easily 14.2 is the most precise. So moving on to this one, this goes to the nearest hundredth, this only goes to the nearest tenth. So then this one, it's easy to say it's 2/100ths of a millimeter instead of 1 millimeter, or 1/10 of a millimeter. And then finally 90 feet or 71 inches. Here we don't look at the decimal place so much as we look at the unit. Which one has a more precise or a smaller unit? Obviously, this inches are smaller than feet, and so it's more precise, it's more accurate. Hopefully that makes sense. This isn't a super complicated topic or concept. It's just we want to develop a mindset where when you're dealing with numbers, not all numbers are like created equal, and not all numbers are the same and have the same value as others. So just keep that in mind. Okay, finally, describe and correct the error in the statement. I'll change colors here. Eric's new fishing rod was advertised as being 4 feet long. He measured it to be 47 inches long. Eric's friend says that 4 feet is the more precise measurement. Actually, no. 47 inches, that's very precise. It's just short of 48 inches, which would be 4 feet. But if you have 4 feet, you know, that's 4.0 feet that could have been without that decimal there at the end. You know, 47 inches can be rounded to the nearest whole foot. So this one is more precise. You can't go back and be upset if 4 feet and 47 inches end up getting treated the same. Okay, so he just had a wrong expectation on this. And we'll talk about this in class. But let's go ahead and move on. Next. Down here, determine the number of significant digits in the measurement. Here, we want to count all of the significant digits, the non-zero digits. So how many significant digits does this one have? 1, 2, 3, 4 significant digits. So what I want to point out is we're looking for non-zero digits here. And these are all non-zero digits, so I count all of them. That's 4. Here though, look at this. I only really have 1 significant digit. This is really like a number to the nearest 100, the nearest 100 space, okay? So I only have 1 significant digit on this one because it's our only non-zero number that matters. All right, now I'm going to move on over to this one, number 7. All these zeros ahead of here, these are non-zero. These are 0, so they don't really count for anything. Like they take a spot, they fill up a place, but they're not as significant as, say, this one. And then I know this is actually a 0, but this shows us that we're extending the number to the tenths, hundredths, thousandths place. So there are 2 significant digits here. All right, for number 8, what are we looking at? We've got 1, 2, 3 non-zero digits, but in between, kind of landlocked in between those non-zeros, are a couple of zeros. That makes them significant. So I have 5 significant digits. Here, I've got 1, 2 non-zero digits. I've got this one hanging off at the end that doesn't really matter, but this one is stuck in between. So here I have 3 significant digits. And then finally, I've got all these zeros at the front. Those don't count they don't count as being significant. So I just have these 2 at the end. So they're 2 significant. I hope this is making sense, and we can talk a little bit more in class if you have questions. Hopefully you would do number 11 on your own. You look at this one and there's only one non-zero digit. All the other ones are ahead of that one. There's really just one significant. Okay, now we want to calculate with significant digits. Perform the indicated operation. Write the answer with the correct number of significant digits. For this one, we want to identify the least precise number. And then our answer is going to only be that precise. So for example, I know that might not make a whole lot of sense right this second, but if I go in and I check, I can see 97.2, that's to the nearest 10th, 16.04, that's to the nearest 100th. This one right here, the nearest 10th place, that's the least precise. So whenever I'm subtracting like this, I go ahead, I subtract these 2, and I get 81.16. Okay, on your calculator you could do that or whatever. But since my least precise number is to the nearest tenths, this one also has to be, they can only be precise to the nearest tenth. So really, this is going to be 81.2. I round to the nearest tenth, and then that's it. Okay. Moving on. When I multiply, I look at it like this. How many significant digits do I have? This one is the least precise because I only have one significant digit. Okay, sig dig. Now when I go and I multiply them, I get 89.6. 89.6. However, I have to write a number that only has one significant digit. So the only number I can write with one significant digit is 90, and that would be square feet. So I know this seems strange, but when you think about it, you know, this number can't be that precise based off the fact we only used 8 feet. This one could be super precise, but if this one's a rounded number, 90 feet's the best that we can do. All right. Just trying to get a new mindset in that way. For division, it's the same thing. How many significant digits? What's the least number of significant digits? It's this one. There's 2 significant digits. I'm going to change colors here. Actually, I'll get rid of this. And, there's 2 significant digits. So that means when I go and I divide these out, my calculator will tell me 107.35. But I have to write a number with only 2 significant digits. So the result is going to be 110. Okay, that's the best I can do. This number, this calculation is no more accurate than this result, this product, because I have to assume that these numbers have been rounded in this case. All right? All right, and then finally, when I add, I'm going back to adding, just like my previous example with subtraction. I find the smallest decimal place, or the least precise decimal place, which is hundredths in this case. I go and I add them together. It's 0.263, but then I have to round to just 2 decimal places, so I get 0.26, and that's it. Now here in this last problem, as we apply what we've learned, this probably makes more sense to you. 3 students were asked to measure the same piece of string. Okay, it's exactly 15.2 centimeters. Well, when they measured it, we got these three different measurements. Who was the most precise? We've got centimeters, centimeters, millimeters. This is a good sign that maybe this person was more precise. This would be 15.4 centimeters if we wanted to write it that way. If that's our answer, then we have to go with Louise, all right? Because think about it, if you measured with centimeters and you just came up with this 15.35, it's not exactly 0.35. You might have rounded that. That could be anywhere in there. And even though that might still seem closer than 15.4, this unit of measurement is smaller. And so we're going to go with Louise as the most precise as far as their measurement. Which student made the least precise measurement? Well, Chandra and Alex both used centimeters, and Chandra was the furthest off. So, sorry, Chandra, you were least precise. And which student's answer is closest to the actual length of string? Well, that would be Alex. See how the precision and the actual number that's closest might not always be the same thing. It's just the level of precision that you use, so that gives you the ability to get the closest. Okay, so that's it, guys. That's all. If you listened to this video and filled out your worksheet with me, you're all done for tomorrow's homework. Please have this ready to go when you walk in tomorrow, and we'll pick right back up where we left off. Thanks. Have a great night.